A couple videos ago, we learned about the story of the quadratic equation, where the great Al-Khwarizmi had written solutions to 6 different forms of the equation. But the cubic equation, an equation with x to the third power, still baffled mathematicians hundreds of years later. The first equation with a solution discovered was of the form here: x cubed plus px equals q, which is known as the depressed cubic for its missing x squared term. The story of the rivalry of the two men who discovered the solution, Tartaglia and Cardano, is one of the most unique stories in all of math's history, let alone the individual personalities of each guy. But this video will focus on the consequences and new math ideas that arose from this result. Let's take a look. The solution of the depressed cubic is this giant formula here. We will use it on this equation here, x cubed plus 6x equals 20, to demonstrate that it works. So, the 6 is our p, and the 20 is our q. Let's plug the numbers in. We have x equals the cube root of the square root of 6 over 3 cubed plus 20 over 2 squared plus 20 over 2 minus the cube root of the square root of 6 over 3 cubed plus 20 over 2 squared minus 20 over 2. Let's simplify that down a little bit. This simplifies to x equals cube root of the square root of 108 plus 10 minus the cube root of the square root of 108 minus 10. Calculating these out, we get about 2.732 minus 0.732. So we know x is about 2. Of course, we can check our work and make sure that 2 is actually a solution by plugging it back into the cubic. 2 cubed plus 6 times 2 equals 20. So 8 plus 12 equals 20, which is a true statement. So we know that our solution works. We can cheat a little bit and use calculus to show that this equation only equals 20 one time. The derivative of x cubed plus 6x is just 3x squared plus 6. And just by looking at it, we can see that this is a quadratic that is always above the x-axis. So that tells us that this equation is always increasing, which means it only hits 20 one time, so we'd only have one real solution. The biggest weakness of this formula is when I simplified everything under the cube root as a decimal approximation. Now I only gave it to 3 decimals, but both numbers here are irrational, so I wouldn't be able to write the entire thing. So I just had to round them and subtract them as it is, but we confirmed later that it is exactly equal to 2. So the formula becomes unnecessarily complicated, which makes us lose accuracy because we're forced to round. Let's consider now this even simpler looking depressed cubic. X cubed minus x equals 0. So p is just minus 1 and q is 0. Well, the easiest way to solve this one is just by factoring, so let's do that first. We have an x in both terms, so we can just factor that right out. So we're left with x times x squared minus 1 equals 0. Well, inside the parentheses, we now have a difference of 2 squares, and we can write this as x plus 1 times x minus 1. So now, by solving each of these 3 pieces of the equation, we get solutions x equals 0, x equals negative 1, and x equals positive 1. So, this cubic equation actually has 3 unique real solutions to it. Now, let's see what happens when we plug in to the general solution for the depressed cubic. Remember, p equals negative 1 and q equals 0 in this case. All these terms with 0 in it will just cancel out. So we're left with x equals, that's hard to see, the cube root of the square root of negative 1 over 27 minus the cube root of the square root of negative 1 over 27. Both of these quantities are the same, so even if we don't know how to handle the negatives under the square root, something minus itself just equals 0. So this whole thing gives us x equals 0. Now the problem is we know that this formula actually has 3 unique solutions, but the formula here only gave us 1. So there's another weakness to the general solution of the depressed cubic. Now in this example we were lucky because q equals 0, so both terms would just cancel each other out and subtract to 0. But if we had a different value for q, we would have been forced to deal with the negative underneath the square root here. So the depressed cubic equation became a very natural bridge for complex numbers and imaginary numbers to emerge. It's kind of disguised in the formula because of our bias towards real numbers, but finding complex answers to cube roots is where we get the other 2 solutions to the formula. That's it for now, but join me in the next video where we finally get to the invention of calculus, which took place during the scientific revolution. Thanks for watching. See you next time.